I'd like to show you today how to sweep in the head of the milling machine. Now this is also called tramming, but whatever you want to call it, what you're trying to do is make the spindle of the machine perpendicular to the table in both the X and the Y axes. Now the head of the Bridgeport has the ability to tilt side to side, and it pivots between these four bolts. If you undo these three bolts on the side of the ram, it allows you to do what's called knotting, which is pivoting front to back. The vast majority of the work you're going to do on a milling machine is done with the spindle perpendicular to the table. You really don't want the head tilted at all if you're going to be drilling holes or cutting slots or trying to make a piece square. So I'm going to be using an indicator holder called an Indicol. That's the brand name. They're made in the USA and they're roughly about $70. You can get them used on eBay for a little bit cheaper. And it holds what's called a dial test indicator. The indicator holder itself clamps onto the spindle right here, just like so. Now this allows you to turn it with the spindle, either side to side or front to back, so you can use the indicator to get a reading. You can also reposition the arm on the indicator holder and the dial indicator itself on that arm. On a dial test indicator, you can move the measuring stylus by pressing it until it reaches the end of its travel. If you continue to press, it will actually slip on its mounting, so you can position it anywhere you need it to be. Ideally, you want the indicator stylus to be 10 to 15 degrees away from whatever surface you're measuring. Otherwise, you get an angular error with your measurements. One thing I like to do is to put a scale or a straight edge down on the table and then use that to put pencil marks in each axis, both the X and the Y. The reason I do this is because it allows me to put the indicator tip on one pencil mark and zero it, and then move it exactly 180 degrees away from that pencil mark. This also allows me to sweep back around to the original pencil mark, and then I know that when I go from here to back here, I'm going to the same location and getting a more consistent reading. When you're adjusting the head, the Bridgeport manual states that you should loosen and tighten the bolts in a certain order. This would be the first, the second, the third, and the fourth. Now when I loosen these, I first start out with the breaker bar, and then you really want to get them snugged back up, finger tight, maybe a little bit tighter with a regular wrench. In this case I'm just using my drawbar wrench because it's handy. You don't want the head bolts to be too loose because the head will have a tendency to move on you when you torque the bolts down. Now you can also snug these down too tightly, in which case the head doesn't want to move when you try to use the adjusting nut. You see this on the dial indicator. The needle won't move at all while you have pressure on the adjusting nut, but as soon as you release that pressure, everything moves. For adjusting the head and the X-axis, this is your adjusting worm. Now this only affects side to side, not the front to back motion of the head. That's a different screw, and I'll show you that later in the video. Now I have my indicator tip directly over the pencil mark I made earlier, and I'm going to go ahead and zero it on this side of the table, and then move over to this side and check the difference. I zero on this side and make my adjustments there because the adjusting knob is on that side. That just makes it easier to see the dial. I use the knee to make all of my zero adjustments because it's a lot less twitchy than trying to use the bezel on the dial indicator. I've set the indicator at a convenient number, in this case 15 on the dial, which is about halfway through the travel of the indicator. Now I'm going to rotate the spindle around until the indicator is over the pencil mark on the other side of the table. The difference between the two readings show how far the head is out of alignment. In this case, that's 15 thousandths of an inch. On the first pass, you want to adjust the head so the indicator barely moves. This is because it has a tendency to move more than you think it does the first time. Now as soon as you see the indicator twitch slightly, 1 graduation or a half a thousandth, you can sweep it back around to the original location and then re-zero it. You always want to return to your original side and zero there rather than trying to go back and forth from side to side, changing where you zero. This can lead to strange readings, and that can be incredibly frustrating. This process is already tedious enough, especially for the beginner, so you don't want to make it any harder than it needs to be. Right now I'm 5.5 thousandths out. You really don't want to try to split the difference between the two dial readings. It seems like you should, but what happens is you invariably end up going too far, and then you start hopping back and forth across zero. So I'm going to go a little bit less than half, and I'm going to sneak up on the measurement. You can see on the dial that I'm just a little over 1/1000th and a half out. Each graduation on this dial is 1/2 thousandth of an inch. So I'm just going to make it move just a little bit, and again, you really want to sneak up on this measurement. You really don't want to go too far. So now I'll swing it back around and re-zero it. As you can see on the dial, I'm just a little under 1/2 thousandth out. As long as I'm within one graduation on the dial, I'm pretty happy with that. So now we get to tighten up all the bolts and make sure nothing moves on us. So the Bridgeport manual also says to tighten them down to certain torque specifications. And it says to tighten them down first to 25 foot-pounds or pound-feet, however you want to say it. Then you check to make sure nothing moved, and then tighten it down to 50 foot-pounds after that. And you do this in the same order that you loosen these. So I've got my torque wrench set for 25. You go until you hear the click. In noisy shops you might only feel the click, so just make sure you don't go too far, because you can keep tightening them after you feel that click. At this point I'm going to check and make sure that nothing moved on me. If you had these bolts snugged enough before you did your adjustments, nothing should have moved on you. And we're still about 3/10 out. So that's good news. Now we just adjust our torque wrench up to 50 foot-pounds, and you do the same thing. Now a quick note about these bolts. They're not very expensive if you strip one out, but they are really difficult to change. These are actually nuts here, and the bolt head is actually back here in the ram. So if you rip one of these bolts out or break it or whatever, you actually have to take the entire head off of the machine in order to replace these bolts. So let's check one more time, make sure nothing moved on us. And we're still about 3/10 out, so we're fine as far as I'm concerned. Now we have to do the back. So for adjusting the front to back, this is a little bit trickier, and I'm going to show you a couple of things that you need to watch out for. First of all, these are the 3 bolts that you need to loosen in order to get it to adjust, and your adjusting screw is up here. Not sure you can see it on the camera, but I'll put my wrench on it so you can see it. Now the thing that makes this really tricky is that your pivot point is way back here now instead of smack dab in the middle of the rotation. What that means is that it's going to move on both front and back a little bit more than you think it is. So you've really got to sneak up on this one. Now I want to show you how I've got my bezel set on my indicator for this one. And I've got it to where it's turned so you can read the 0 at the 3 o'clock position. And that makes it very easy to see where the needle is in relation to 0. You're going to be doing all of your adjustments on this side. So you're going to 0 on this side and then move over to the front side of the table to make your adjustments. It has to be that way because if you did it the other way, the needle moves in the opposite direction that you think it should on the indicator, and you don't want to do that. That's a source of confusion for a lot of people. So 0 it on the back side of the table, move the indicator to the front side of the table, make your adjustments there. Let me reposition the camera again and we'll get started. So I've got the indicator 0'd on the back side, and I'm just going to sweep it around. And you may or may not be able to see, but I'm off by about 1/1000th of an inch. Now this adjustment actually makes it very easy on you because as soon as you release the bolts on the ram, the head has a tendency to flop forward. So that means that all of your motions are going to be clockwise on the adjustment screw when viewed from the top. So I'm just going to make it move a little bit and then sweep it back around and see what we get. And I'm about maybe 7/10 out. So I'll get that to move just a little bit more. And this one you really don't want to accidentally go across 0. You don't want to go too far, because the second you take any tension off of the worm at all, it's going to flop forward again and then you're going to be restarting. Okay, so you can see there I'm about maybe 2/10 out. So I'll go ahead and call that good. And we do the exact same thing with these bolts as we do with the other head bolts. We do them to 25 foot-pounds and then 50 foot-pounds. That's sweeping in the head. You also have to sweep in the vise, which I'll show in a separate video, and I'll put a link to that in the comments. I've also got a video showing the bad things that can happen when your head is actually out of tram, and I'll put a link to that in the description as well. Thanks for watching, and I hope this helps.